The Windows Azure platform includes a number of components that can be used by applications running on a variety of systems. One of these components is Windows Azure Storage, part of the Windows Azure platform, which provides persistent and durable storage in the cloud. So let's take a look at the stored infrastructure of Windows Azure Storage. Each item in storage is stored in triplicate, and this is true for all items of Windows Azure Storage. The backend store is the same for queues, tables, and blobs, and we'll talk more about those in more detail. And the Windows Azure Storage is just a REST service running on Windows Azure, so it's very easy to gain access to your Windows Azure Storage. So what is Windows Azure Storage? It is storage in the cloud. It is scalable, durable, and available, and you can get access to your Windows Azure Storage anywhere at any time. And the great thing about this is that you'll only pay for the services that you use and the amount of storage that you use. Windows Azure Storage is exposed via a RESTful web service. You can use this from Windows Azure Compute, and you can use it from anywhere on the internet. You have a large number of storage abstractions, and we'll talk about those in more detail in a minute, but these include tables, blobs, queues, and drives. To get started using the Windows Azure Storage, you need a Windows Azure Storage account. This is user-specified with a global unique account name. When you create your Windows Azure Storage account, you can choose your specific geolocation to host your storage account. So North Central or South Central in the US, again 2 in Europe and 2 in Asia. You can also include your CDN-enabled account, which delivers blobs via more than 20 global CDN nodes. You can co-locate your storage accounts with your compute account, which decreases your storage costs and increases performance. The key to this, though, is the 2 independent 512-bit shared security access keys. We'll talk more about those in a minute. And what's even better is that each storage account can have up to 100 terabytes per account. Let's talk about the storage emulator for a minute. The storage emulator resides in your local development environment and provides a local mock storage. It emulates the storage in the cloud, and it allows completely disconnected development of Windows Azure apps, so it allows offline development quickly and easily. It does require that you have SQL Server or SQL Server Express 2005 or 2008 or above. And there are some differences between the cloud and your development storage. There's a few, but using the storage emulator, you get well over 90% of the cloud development within your emulator. Windows Azure Storage Services uses a strong storage access key to control access to storage accounts. Your Windows Azure Storage Service has a simple access control module. Each Windows Azure subscription can create 1 or more storage accounts. Each storage account has a single secret key that is used to control access to all data in that storage account. So access to that data in a specific account is only granted to entities having the secret key for that account. This supports the typical scenario where storage is associated with applications and those applications have full control over the associated data. Now, these storage access keys are randomly generated when the storage account is created, so there's no way that you can guess what the next one is. And a storage account may have 2 active keys at any given time to support key rollover. If one security key is encrypted, you can disable that one and generate even a second key and make the existing second key your primary and generate a new second key. And data access can be protected using SSL encryption to even further secure your data. So let's talk about the Windows Azure Storage abstractions, the specifics of Windows Azure Storage. They include blobs, which are simple named files along with metadata for the file. You have drives, which are durable NTFS volumes for Windows Azure applications to use. These are based on blobs. You also have tables, which is unstructured storage. A table is a set of entities, and an entity has a set of properties. You also have queues. This is a reliable storage and delivery of messages for an application. Think of it as a very simple MSMQ type of application. The great thing about accessing storage is you can do it with REST. You can use the library when it isn't available, but the library is only available with .NET 3.5 SP1 and above. So if you're using an earlier version of that, you can still use REST to get access to your Windows Azure storage. The great thing is, even though if you're using REST, all features of the access storage are available. It does lack IntelliSense, so if you're using the library, you do get the IntelliSense and all the features of the IntelliSense. But the downside of using the rest is it does result in confusing and opaque code. But let's talk about using the library. There are storage client libraries for most platforms, .NET, Java, and others. So you got .NET, you have Java, they even support Python and Ruby, and they even support PHP. Now the library is just an abstraction layer on top of the REST API, and this is the most common way to access storage. But again, it only supports .NET 3.5 SP1 and above. However, with the client library, it is automatically referenced in a cloud project, and it supplies a nice .NET API on top of the REST API. However, you will need the following: an account name, the shared key, which we talked about, and an endpoint. So all endpoints are, for example, blob.core.windows.net or tables.core.windows.net. And if you're doing local development, you must set use development storage equals true. So if you're doing storage development, there are certain connection strings that you have to set. So if you're doing local development storage, you have to set the data connection string and set the value of use development storage equal to true. But when you deploy to production, or in other words, if you deploy to the cloud, you want to include this information in your configuration file. You don't want to hard code your account name and your account key and your application code. You want to put that in your configuration file. So let's talk about the object hierarchy. And as we talk about tables, blobs, and queues, you'll see some similarities between all three. Microsoft did a really great job of planning how the Windows Azure storage works. So it's basically this: you have the cloud storage account and the cloud service client and then the cloud object. For example, if I have a cloud storage account, that has one or more cloud table clients, and then from a client to the specific table, blob, or queue. The only difference in this scenario, however, is that from the blob perspective, you'll have a blob client, and then a blob client can have multiple blob containers, and each blob container can have multiple blobs. But the scenario is the same. It starts with the storage account. You have one account can have multiple tables, and one table can have multiple table queries or entities. Same thing with a queue or a blob. One account can have multiple queues, one queue can have multiple cloud queues. Same thing with blobs. So let's talk about partitions, because this is going to be critical when working with Windows Azure Storage. Partitions are used by the storage fabric as the unit of scale and redundancy, meaning each storage type defines a partition differently. For example, for a queue, one queue equals one partition. For a table, one table partition equals one partition. And for a blob, one blob equals one partition. Partitions are used by Windows Azure Storage to determine performance and redundancy. How is Windows Azure going to scale out? And this is all based on partitions. So let's take a better look at partitions. Windows Azure does a good job of moving around partition on the storage servers by itself. This is nothing that you have to do. Partitions are moved around the storage servers to maximize performance, and this is done automatically. This is nothing you have to code or you have to do. There's a topic called hot partitions, and hot partitions may be scaled up, and we'll take a look at this in a second. But this is controlled by the Windows Azure Fabric. The Windows Azure Fabric may dedicate more resources to partitions with a high transaction load. For example, if it notices that one partition is getting hammered by transactions, it will automatically scale out those partitions and break those partitions up to improve performance. Now, one of the overriding themes that you'll notice in Windows Azure is that everything is in triplicate. Thus, each partition has 3 replicas with one master. However, behind the scenes, Microsoft keeps these up to date automatically. So when writing to a partition, the operation is complete when the data has been written to the other 2 replicas. So even though there are 3 replicas, those replicas are always in sync, and this is done automatically behind the scenes by Microsoft. However, the operation is not considered complete until the data has been written to all 3. But keep in mind, though, and what they say is that the 3rd replica is updated asynchronously. The first 2 are updated synchronously. Let's take a look at replication behind the scenes. So here I have on the left, I have one logical partition. It's one storage partition. But I have 3 replicas of that logical partition. The goal here is that we don't care where they're at or what server they're at. The idea here is that I have 3 replicas and they're always in sync. So let's take a look at how it writes to these replicas behind the scene. We know that it writes to the first 2 and then it writes to the 3rd asynchronously, but they're always in sync. Let's take a look at recovery as well. We know that there are 3 replicas of every partition, but the great thing is that Microsoft is managing those partitions. So if one of those goes down, it will spin up a 3rd on some other location and make that the 3rd replica. So let's take a look at on how partitions scale. Partitions are fanned out based on load, and they can be condensed when load decreases. So Microsoft behind the scenes will keep track of each partition, and as they start getting hot, or what's called a hot partition, Windows Azure will fan those out based on the load, and then if the load decreases, they can be condensed when that load decreases. So let's look at an example of how these partitions are fanned out and condensed based on load. Here we have server 1, and it's got partition 1, partition 2, and partition 3, whatever. Let's say, for example, the partition 1 is becoming a hot partition, thus putting a performance decrease on the other partitions on that server. So what Windows Azure will do is that it will actually move that partition over to server 2 to increase performance. And then let's say for down the line, partition 2 becomes a hot partition. Windows Azure will actually move that to a whole nother server, in this case server 3, to scale out and increase performance. Then over time, as Windows Azure determines that the load is decreased, it will actually move those replicas or those partitions back to server 1.